I'm just gonna say it's my first time being at DevOps Days. I'm gonna tell y'all right now, I am super excited to be here. And I'm also super excited to talk about this side project of mine. So it's not necessarily related to anything that I do at Citi. It's just something that I started doing on my own when I noticed that there was a significant gap, I would say, in AWS's Macie's framework. So the first thing is that what we're going to be talking about today is automated S3 blocking with AWS and DataCop. So I'm pretty sure you guys are probably wondering, well, why should we even block S3 buckets in the first place, right? So you can say over the past couple of years, there's been quite a bit of data exfiltration attacks at targeted S3 buckets, right? So you have, for example, Netflix is one of the bigger companies that everybody knows about. That happened a couple of years back. I don't necessarily remember what year, but their S3 bucket was exposed. And if you look at the picture on the right, there's basically some exposed database credentials from Netflix's S3 bucket, and it has the name, the connection string, even has the authentication token, which is pretty bad, right? But in most cases, most of the data that has been exposed from most of these S3 buckets, you have personal identifiable information, or PII. So PII stands for, you have social security numbers, first name, last name, tax identification numbers. Those are the things that will classify as PII. And then you also have credentials and tokens, as hence the Netflix database credentials that were exposed. So the reason why data exfiltration is a thing with S3 buckets is that most companies lack the access control. So, when they have roles assigned, it could be mismanaged or misassignment of those roles to those S3 buckets. There's also lack of monitoring. So a lot of people don't necessarily know what data comes in and out of those S3 buckets. Some people just have, like, within one account, maybe 100 S3 buckets, but they don't necessarily know what's inside of each of those S3 buckets. And most importantly, both of those could be an example of misconfigured S3 buckets or misconfiguration, right? So before I even get into explaining all of the other tools and technologies, we're going to come up with a scenario, and this scenario we're going to use throughout this entire presentation. So I have this company that I created. It's called Generics. Well, not actually created, but it's an example organization. And it's basically a mobile gaming company. And the key thing about it is that they cache server and user data within several S3 buckets within a single account. And within that single account, of course, they're utilizing several AWS services such as EC2, Lambda, code commit, code build, blah, 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 because the majority of their infrastructure is deployed into AWS. But they do have a little connection to on-prem. But within the past year, you can say that that organization has sold over 1,000 copies of their hit mobile game called Angry Dolphins. I don't know why dolphins would be angry, but something I had in my head. But with this company, they have this data compliance policy or classification policy that they have to enforce to be able to protect their users because they're selling games, right? So more than likely, or most likely, they're going to have some PCI and PII data associated with those, right? So what happens is that they need to ensure that their S3 buckets are not publicly accessible because of this, and they have to ensure that they're both prohibiting storing internal data and that customer data within that AWS, right, or S3 buckets. So because this company is still small and they're scaling to meet the demands of the business or the customers that they're trying to supply, there's been an influx in the creation of S3 buckets. And at this point, management or the CIO, whoever, decided that they want to use Macie to execute a scan job to see what data is being inserted into these S3 buckets. So I know pictures say a lot of words, so that was a lot of words on the last presentation. So let's talk about or look at this architecture diagram. So here we have this single account is level 1s, and within this account, we have 6 S3 buckets. You can see that 2 of the S3 buckets are locked, and they're highlighted, color-coded as green, which is basically solidifies basic log data. But the gray buckets, we don't necessarily know what we have in them, right? Because this app team, they decided to create these S3 buckets, and they're just inserting data into them, but we don't know what exactly is in here, right? So in order for us to be able to determine that, again, we're going to use Macie to do that. And that's when we get into the S3 monitoring solution called Macie. So it's basically this service that AWS created, and it provides it's a data security and privacy service, and it leverages machine learning and pattern matching capabilities to be able to discover the sensitive data that we have in AWS, specifically in S3. When you execute a job or you create a job, the beautiful thing about it is that it is account specific and region specific. So it will give you a list of those S3 buckets and classify them based on whatever data is defined in them. And we'll talk about that more in a little bit. But the thing about Macie is that it helps those organizations that leverage it meet those data compliance regulations such as GDPR, HIPAA, FedRAMP. All that's taken care of for you by Macie. So there's a couple of pros and cons with Macie. We're just going to go through them. So the first thing that is a pro that I really like is that they have fully managed sensitive data types. So those sensitive data types is fully managed by AWS. So they supply them. If you take a look at the picture on the right, you see that we have example of social insurance numbers, SINs, SSNs, and also text identification numbers. All of that is supplied by AWS, and it's not necessarily restricted to just a nation. They have global managed data types that apply to every nation. So you can have social security numbers in China, for example. It'll pick that up when they go and scan through or parse through those objects. The key thing about this is that it seamlessly integrates with all the other services, so such as EventBridge, CloudWatch, and Step Functions, which we're going to talk a bit about those in a bit. If you're an organization and you want to specify your own data types, you can. So it has the ability to be able to add customized data types and fields for that data classification, so you can classify your own data and risk if you want to. And the thing is that with these jobs that you can create, you can also automate the sensitive data discovery jobs, and you can run them on a specific basis. So you can run them daily, nightly, weekly. You can do it whenever you want to. But the cons of this, however, is that it's expensive. And because you use machine learning and all this pattern matching technology on the back end, the numbers and the price run up quite quickly. When the job is finished, it returns a JSON file. And the problem is that JSON files that can be exceptionally bloated. So with that JSON file, let's say if I scan like 100 S3 buckets within one single scan. If it finds anything within those 100 S3 buckets and it classifies them, it's going to be inserted into that one JSON file, because that one JSON file is linked to a specific job. So that JSON file can probably have between maybe a couple thousand records to maybe even 1 million, depending on how many S3 buckets you're running or you're scanning, right? And the last thing is that there's no feature available for auto remediation of those buckets. So let's say if we do have an S3 bucket that is classified as a high risk, and we know that high risks are not what we want for the business, what do we do? And Macie is just like, oh, okay, well, it's high risk, so that's, why would you, so that's the only thing that it doesn't have, and that's the thing that we're going to bridge the gap to. So no auto remediation. It's just telling you that there's a high risk and you have to figure that out on your own. So the next thing is that we have the scenario. Remember generics that we talked about, that company, Angry Dolphins, user identification data, and so on and so forth. This architecture diagram is an example of a security engineer who took that thing for his management, and he decided to execute a job against those S3 buckets. So those S3 buckets, remember we had 2 green ones and 4 gray ones. Now they're color-coded, the 4 gray ones, right? They're still unlocked, unfortunately, but they're color-coded. And you have a purple bucket and you have a red bucket. So the purple bucket is the internal data. I don't know why they're storing it there. And there's also the red bucket, which is PII, SSN, and PCI data, right? Which is the same thing as PII. So if you look on the right, those are some example results of everything that is found in the bucket. So you can see that Macie categorized the bucket as a high risk to the business. And it also, you can see that we have some financial information. There's like 4,000 credit cards and over 50,000 SSNs. So that's really, really bad because we're not supposed to be storing that in AWS anyway. And it's unlocked, which is horrible. So the question that you guys think is, if we wanted to manually block those S3 buckets after a Macie scan, what exactly would that look like? And then this is where we get into exploring the manual blocking, right? So let's say we have that high risk, right? And we want to block those buckets that are of a high risk. The first thing that the security engineer is going to do is they're going to check the Macie's results bucket, which is going to contain that JSON file. And then what they have to do is that they have to download that JSON file, and they have to go through it and parse through that JSON file manually. Now, if you had over 100 S3 buckets and you're trying to parse through that manually, that's a very painful task. I wouldn't want to do that. So you have to parse through it manually. You have to go and see the bucket name, and you find the severity of it. And it's like, OK, this is high. Then we say that if it's a high risk, then we have to take that bucket name, write it down somewhere, and then navigate to the AWS S3 bucket console, and then we need to go and block the public access for it, and then block all the other access for it, and define a bucket policy, which is horrible, right? We have to do all of these manual steps, all this clicking and all this stuff in a console, and then when we finish, we click done. But that is just for one specific bucket. So imagine doing that for 100. Right? So downsides of doing that manually is that it's time consuming, for one. The next thing is that if you're a user and you're going through the JSON file, right, and you're going through it line by line by line, you most likely will end up making a mistake. You might end up blocking the wrong S3 bucket if there's similar names, right? And some companies do use similar names to their S3 buckets. And it's not scalable. You only have, even if you had 10 people on the team that's doing the same thing, it's still not scalable, right? So you can't do this manually. There has to be some type of automation to this, right? So this is where we get into this framework that I developed called DataCop. So DataCop in itself it's open source. I open sourced it, but essentially it sits on top of AWS. And it's a framework that mitigates the potential of those risky or vulnerable S3 buckets for the business. And what it does is that it takes those Macie results and it automatically it pulls out that S3 bucket and automatically blocks it depending on the classification that the user or company has provided for us. So some of the features is that it automatically provisions the infrastructure to bridge the gap between Macie and S3 with AWS CDK and Python. It has configurable settings for bucket blocking, so the company can specify the settings that they want. And it's also event-driven. So that's actually a really important thing, is that it detects when a result or a scan has finished, and it'll basically pull that information and go ahead and do its work. So you're probably sitting up there, and you're just like, well, it's all automated. That's nice. So there's some considerations behind this. So the thing is that in order for all of that to work, for DataCop to be able to do its job, we need to be able to create, or it has there are a lot of IAM permissions and policies that we need to create in order for it to be able to utilize the following services, right? So we have EventBridge, Lambda, CloudWatch, SNS, and Step Function. EventBridge, that's an AWS service that pretty much that DataCop will leverage in order for the S3 bucket it'll detect what results are being put into the S3 bucket. The Lambda is going to be the serverless component that's going to execute those blocking actions. CloudWatch is just for the logs for both the Step Function and Lambda. SNS, Simple Notification Service, that is what it's going to use to send an email out to the users to notify them of when a bucket has been blocked. And then a Step Function is going to give us a visual workflow. So it's going to execute these steps in a specific order, right? The good thing is that DataCop creates all of those roles and permissions for you. So the only thing you have to do is just simply run one command, and then it'll create all the roles and permissions. It'll even create the step functions and all the stuff that you need. But if you're an organization that you want to use it and you have some SCPs that explicitly block using EventBridge or CloudWatch, I don't know why you would do that, but it definitely won't modify any of those SCPs that you have created. And that's an intentional thing. So let's say we have DataCop deployed already, and it's deployed into this one account. for generic. So the security engineer, he got smart because he said, I ain't about to do this. So he went ahead, he still executed the job, but DataCop is already deployed in an environment. So the next thing is that, what will DataCop exactly do, right? So this is where we're gonna get into the architecture of DataCop. So the security engineer executes the job gives us all the results, and it classifies the buckets automatically for us. Macie then uploads those results into their own S3 bucket, right? Which DataCop is already configured. So it'll create the bucket for Macie to upload the results into. And what happens is that EventBridge will, since it's already monitoring that bucket, in a sense, once those results are uploaded, then DataCop is going to take that, EventBridge is going to take that event and is going to send it straight to the step function. And that event is going to have the bucket name, it's going to have the file that is uploaded, and so on and so forth. And then the step function itself is going to interact with the Lambda function, right? Which has the execution role and all the roles it needs to be able to handle these actions. And it's going to execute a sequence of steps to be able to block those S3 buckets. And then when it's all done, whether it passes or fails, because in some cases it may fail, it's going to send a notification out to those users, which is the sixth step, the SNS topic. And then, of course, if you want to look at the logs, everything is logged in CloudWatch log group that it creates for itself as well. So fast forward, let's talk about the state machine, because we want to know exactly what type of actions are being carried out, right? So the state machine for DataCop has about 7 total states, and a couple of conditional statements or states. But the key states that we want to talk about is determine severity. So the first step, when it determines the severity, that's when the event is coming in, and it's going to parse through that event. It's going to take the parse through the JSON file after it's downloaded, and it's going to check to see what the classification of it is. And in this case, if it's a high, then it's going to go and it's going to ask, do you want to block the bucket? And if it's a high, then it's going to say, OK, cool. Let's go ahead and check the bucket status. So when it checks the bucket status, it checks to see if the bucket has already been blocked. Because in certain cases, it may end up trying to block the same bucket before. And if it has previously been blocked, if not, then it's going to go ahead and it's going to block the bucket. And when it blocks the bucket, it is essentially stopping public access, so no one has public access to it. And it's attaching this bucket policy that is going to deny everyone access, even if it's within a business, except for the associated role with DataCop. So if you're the security professional that has access to a specific role, then you have access to that bucket, and you can go and you can search through the data and see what happened. But anyone else in the company would not have access to it. And then when it's done, it'll send a nice report, and it'll also send an error report if it fails. So this is what it looks like, right? So once we scan, we execute the job, and it scans, it sends the results to the bucket. The third step is go straight to DataCop. DataCop detects it. And then the fourth step is it blocks those buckets. So you see it's a deny all bucket policy is attached to those four. Those 4 buckets that were now purple and red are now black. And they're also isolated, meaning that they're in a separate, that means that the not all bucket policy is attached to them. So no one can access those buckets unless they're authorized professionals or personnel. And then a restricted access, meaning that, of course, now it's no longer public, it's actually blocked. And then once that's finished, then you have the 5th step, right, which is going to send that nice email. So you see there's a nice example of the email there stating the name of the bucket that was blocked, or buckets, because it can block several of them. And then there's also a execution ID is associated with it, right? So if the engineer wants to go back and look at the execution ID in the step function, they can look back and see what happened. So it can ultimately traceability. So the benefits of DataCop is that it eliminates the complexity of those repetitive and mundane tasks for blocking S3 buckets, so you don't necessarily have to do it manually anymore. And that's a really good thing, because no one wants to be staring at hundreds of thousands of lines of JSON code. It's just, it's horrible. It also eliminates the potential for human error, so you're not necessarily taking, you're not parsing through anything manually anymore. So everything's automated, which is actually really good. It's reduced response time. So let's say if this is an incident, someone's already into your bucket and you just got the Macie's results and you're trying to hurry up and lock down all the buckets that have public access or has those sensitive contents, it automatically pounces right on it because it's event driven. So you don't necessarily have to worry about it taking a week for you to block 100 S3 buckets. It takes care of it within a matter of minutes. And then that also comes to the town as being scalable. So again, 100 S3 buckets may take a week. 100 S3 buckets with DataCop may take about a couple of minutes or an hour, depending on how long the scan is running. And with that being stated, that's really all that I have for y'all. Thank you so much for listening. And if you want to scan the QR code that has links to the DataCop code base, it's already open source, so it's on GitHub. And it also has links to my social media and professional content or whatnot. And shout out to DevOps Days Dallas, the organizers, for such a great conference and for allowing me to speak. Thank you so much.